Okay, I want to help you fill out some of this information for the sticky tape lab. So we're going to start by putting some little marks in the top tape and the bottom tape to represent our electrons. So right now, we think about the way the Thomson model is. Remember, he said that the electrons, that there was negative parts and positive parts, and that they were just out there like a plum pudding. So when we put them together, we find that the bottom tape actually attracts the electrons. So one of those is going to be moving into the bottom tape, and that leaves only two in the top tape. So when we pulled apart the tapes, that left the positive, or the top tape, to have a positive charge, and the bottom tape actually took on an extra electron or some electrons from the top tape. So what we want to talk about is when they're placed together like this, one side was stickier than the other, and as far as the electrons are concerned, when the top tape separated, they were then moved to, or they stayed with the bottom tape. So we're going to say the bottom tape attracted electrons, and we'll say given off by the top tape. Now, when they had a charge, then they were attracted to each other. Once they were charged, we'll say once charged, the top tape and bottom tape attracted to each other. Okay. You can pause that anytime so that you can copy down what you need to see. So in this part, we're reading about how the metal foil and the non-metal, the paper, would attract each other. They both attracted both charges. But what would the plum pudding model do in order to explain that? Well, let's see if we can do that with some pictures. We're going to first think about the non-metal paper, and let's go ahead and put some electrons, and we're going to let these be our plum pudding bowls. And so I'm just trying to very quickly add electrons. I want that to be 3. And then I'm going to also consider how if the top tape as the top tape was coming close to the non-metal and the tape comes near, then the electrons are able to shift just a little toward the positive. So let's see when the when the metal foil, let's go ahead and put some electrons in. When the foil also has the plum pudding electrons are all spread out, if, according to J.J. Thomson, if they're all spread out, what the metal foil does, because it is a very attractive force, it's as if all the electrons have shifted toward the positive. I'm not counting those, but you can see. So the way this could explain what we saw with the tapes is that the electrons are able to freely move around in the metal. They are not able to move away from their atoms inside the paper. But why this would give such different attractions is that nonmetals are poor conductors. The paper doesn't allow the electrons to flow. They are insulators. But the aluminum foil, being a metal, is a very easy conductor I'll say conducts electrons easily. So the bulk flow of electrons is possible in metals. The electrons tend to drift to the atoms on the side of the strip closest to the positive tape, and the greater shift of charge accounts for the greater attraction between the top tape and the aluminum. So you can see here that the electrons have shifted toward the top tape in the aluminum foil, where they are not able to shift that far in the paper.